Hey, good evening, everybody. We've got a little bit of a late show tonight, and we're checking out the weather this evening. This is what it looked like earlier. Had a few build-ups to the southwest as the sea breeze rolled through. Made for some pretty good time lapse there, but we didn't get even a drop out of that stuff, so we shall try again tomorrow. But anyway, this is what it looks outside like at this moment. Not much going on. And I moved the cameras around, and this is kind of what I call the scorpion cam, and I'll show you why. Let's see here. Yeah, that's the camera that takes this footage. I've got it temporarily mounted near a tree, and you kind of pan down to where there's all this pine thatch and stuff like that, and for some reason the resident scorpions we have like that area a lot. So I don't get them in the house or anything like that. They're just outside and they're curiosities, and there's one hiding right there. So that's what we're looking at when we're checking things outside, looking out to the southwest there. Pretty much clear skies at this time. All right, heading into the charts. Let's see here. Yeah, let's get that set up. Okay, I got to go back to the beginning here. I've got about 30 charts up. And we start with the prevailing flow here, showing the southeast winds across Texas. We've got the very classic summer-like gradient coming up from the south. So south winds here in Texas, and feeding this little area along what's probably a dry line in West Texas, and the cap rock in the panhandle right there. And moisture fields are looking like this right here. Looks like we got some pretty decent moisture there. Showing the green. Those are going to be the 72-degree dew points. So dry line located from about Dodge City all the way down to Amarillo, to Lubbock, and then back towards Monahans. So it looks like the storms did fire along that and moved out to the east. The deeper moisture out along the Gulf, we've got 76-degree dew points down to the south. And is there a moisture axis? Maybe a little bit of one right through here. It's very broadly defined. Probably looking at something like that, some of the deeper moisture right there. If I really want to find where the moisture axis is, that's where it can help to go to the model data. And there's an 850 millibar chart there, and that gives you an idea of the vertical structure of the moisture. So there's that chart, and there's the current data. So anything about that's in the blues is going to be your 60s dew points, and it looks like that runs pretty much right up the I-35 corridor up to Oklahoma City and up towards the Kansas City area, and a secondary band just ahead of that dry line cold front in Nebraska and South Dakota. And they have had some severe weather out in that area today. I was looking at that earlier, and let me scroll back to that. Got a tornado watch box up for southwestern Minnesota into the southeast South Dakota area. And let's check out the storm reports. Looks like lots of hail. That's going to be the blue right there, the hail reports. Kind of a south, southwest, north, northeast progression there, and a few red spots indicating tornadoes. So pretty much from south of Fargo in through the Aberdeen area, and then down to, I guess that would be just west of Yankton. I know there's a lot of tribal land in this area, and I don't know all the town names in that area. Few wind reports all the way down the dry line into the Texas Caprock area. And just a quick review of the tornado reports. Trying to find the biggest tornado. Looks like there's been a few of them. One definitely in Stevens County, Minnesota there. And looks like a couple of larger ones in the Han County, South Dakota area. So we're talking Zell, South Dakota, Hancock, Minnesota. And maybe this is a good time to load up GR Level 2. There's not going to be much left out there. You can see we've got things kind of clustered together in a squall line at this point. Okay, so there we go. From northern Minnesota almost to the Minneapolis area, and you can see a little bit of an outflow boundary right in this area, so a little bit of outflow dominance on the storms. Don't see anything that looks like a bow echo, and for that I'm looking at rear inflow notches. Structures like that, that's going to show up a little bit better on the site radars, but as we get further south we get more into multi-cell type storms. A little bit more discrete there around the Lincoln, Nebraska area. So probably the best radar to look at would be Minneapolis. So we'll bring that up, and while we're waiting on that, we'll continue looking at some of the other charts. And for the northern plains, a good chart to look at, again, would be moisture. So we can see what's feeding this stuff. And again, we're looking at the shading. So I've got 66 degree dew points right in this area. Looks like a little bit of a moisture deficit right in that area. And then 68 around that. Contour is a little bit hard to read, but looks like one little moisture axis right in this area here, south of Minneapolis, all the way down to southwestern Wisconsin. And it looks like some of the better storm relative velocities are in this area right here. You can see the winds are a little bit more backed in that area compared to down south, where the storm motion is probably to the northeast and not really making good use of that southerly storm relative flow. Let me see if they have a storm relative flow product on here. That's a good question. Storm relative wind, surface through 2 kilometer. That's going to be the inflow layer. So, yeah, it looks like about 20-30 knots from the east, feeding that MCS pretty well. And looks like even maybe down south, a little bit of good storm relative inflow. I guess maybe these cells possibly heading more southeast. So this is a product you can look at to kind of assess the moisture coming into the storms, and the stronger your storm relative inflow, the better your storm organization will be. Let's see, I was going to try to bring up the webcam. I haven't used that in a while. I'm trying to figure out why it's not working here. I guess I'll have to mess around with that tomorrow. Okay. Yeah, I think back a couple of weeks ago when I was working with a webcam, that was kind of a popular thing. That way I could talk directly to all of you, but Yeah, not much having luck with that. I'm playing with this setting here, and video not really coming in here. So anyway, we'll probably just see if that works tomorrow. Okay, continue on to the charts. There's a 250 millibar chart showing long wave ridging across the U.S. And then we have troughing off the coast, off the Atlantic and the Pacific coast. And then buried within the ridge is this very high amplitude trough going through Montana, the Dakotas, and Nebraska. And some of the stronger flow right out ahead of that in the South Dakota, Nebraska area. And that's the reason we're getting some severe weather in that area. Polar front jet coming on shore there in Washington. We also pick up the polar front jet in this area. And actually a better chart to look at is going to be the UCAR charts. So there's the 200 millibar 0Z chart. And we can see 90 knots right there in Bismarck. That's some pretty good bulk flow, or that will provide for some good bulk flow in that area. And then we have 50 knots further to the south in this area here. And we are picking up a bit of the subtropical jet. I don't know how many of you can see that, but there it is. Running from Albuquerque to Oklahoma City and then diving southward anticyclonically to Louisiana. So we are pretty well capped. If we had a way to overcome the cap, we could get some pretty organized storms. And I think we did see that a little bit earlier out in the panhandles today. 500 millibar chart showing the stronger polar front jet. This is scraping the bottom of the polar front jet, but we're seeing 50 knot flow through this area, 60 knots right there. And then the mid-level flow at 700 millibars, also pretty strong through this area, 35 up to 60 knots along that MCS there. Then once we get down to 850 millibars, we're down at about 5,000 feet. We're looking at the moisture. And in this case, we have dew point depression instead of dew point. So you do have inconsistency between all the different models. So to actually get dew point, we have to subtract out the bottom left number from the top left number. So at Springfield, dew point 16, 15 there at Oklahoma City, and at Shreveport, looks like 15 there. So that can be a bit tedious, and if you don't want to do that, you can always go to the SPC chart, which I'll do right now. Now you may wonder why some analysis sites use dew point depression, why some use the actual dew point values. Well, with these other sites, this can be useful for flight weather forecasting because all you have to do is look for low numbers, and that tells you where you have fairly high relative humidities and good potential for cloud material. Anything that's about 5 or below is conducive to cloud formation. So pretty much anything in this area, we would be looking for clouds. So that has aviation weather impact right there. But for severe weather forecasting, we don't want to look at dew point depression. We don't want to look at relative humidity. We want to look at mixing ratio and dew point. So there's the chart there from SPC. And we're looking at actual dew point values. And the highest values that I'm seeing here very broad moisture field. I guess I'm seeing maybe 17 here around Omaha. Probably 16 there at Topeka and Springfield, and 16 up at Minneapolis. So that would be your moisture axis there in the Midwest. So some pretty decent moisture feeding those storms. 16 degrees, that's going to be 61 degree dew points. Now we'll head to some of the other charts and look at the 925 millibar analysis. And we're back to dew point depression once again, but we can see maybe a little bit of a low-level jet starting to pick up here. We've got 30 knots, 35 at Topeka, 35 in Omaha, and 35 there up in Minneapolis. So maybe we're going to look for the development of a low-level jet in this area. You can see this gradient, the black lines from Texas all the way up to Minnesota. That's where we have a strong height gradient, and that's going to be pretty conducive there to the formation of a low-level jet overnight. So we'll watch for maybe things cranking up there for Missouri, Iowa, maybe the Kansas City area for tomorrow. Then we head to potential temperature. What changes have we seen on this? We've been looking at this chart for several days. We've seen the strong heating in the desert southwest kind of recede a little bit because we've had some cold air moving through the Four Corners area. Now, I guess one thing you could do is maybe go with a front kind of like this. Another possibility is this whole area has been wiped out by cold air, because I remember seeing values up to about 48 to 50. These are potential temperature values, and they were a lot higher earlier this week. So it's possible the front has actually moved eastward into the high plains. But up in Minnesota, we can definitely pick out the front in that area. There's the warm front from about Minneapolis down to Peoria, Evansville. It looks like maybe a little bit of that extending, kind of connecting all the way back to Ohio and Pennsylvania right there. And then again off the coast here. So that's the polar front jet well up to the north, and the moisture is on its way north. Let me see if I can bring up digital atmosphere and get a current plot. This is what I want to work on later this evening. I've really got to get a updated version of this out, as you can see, and I'm kind of ashamed of this. 2009, I haven't really updated this in several years here, and I've got an in-house version I've been working on for years, but it's been like one thing after another, and I really got to get this out the door. I'm hoping to have kind of a nice quiet night and be able to work on this in Delphi, my compiler, and get a newer version out, and that'll get us the additional station tables. Of course, there's been a lot of changes since 2009, so we want to definitely have those. Okay, current weather. We'll plot this here. Very cold up in the Northwest Territories and Nunavut. Would love to be up there right now. Those 30s sound nice. If we go further to the south in the Midwest, and this is where we see if we can identify the front. The best thing to do is start from south to north. And I've talked about the imaginary car drive. You're driving from Kansas City, 81 degrees. South winds there, humid, 69 degrees right there. Okay, so that's definitely tropical air. You drive up to Des Moines, same thing. Even up to Minneapolis, same thing, 82 over 70, very humid. Wow, 82 at this hour in Minneapolis. And then we get up to Duluth, big change there, 53 over 50. We've got ceilings at 2,000 feet. And if we go even further north, we get into a little bit of rain and thunderstorms. So we've definitely hit the front somewhere north of the Twin Cities. Okay, so similar procedure from St. Louis, 85 over 68. We go up to Chicago, 74 over 64. That's kind of depressed there. Then 71, 63, gradual fall off. Yeah, I'm going to go with maybe the front being right in that area there. So that's the procedure you go through, trying to find the boundaries. And you would keep track of these overnight because these are going to be relevant to your forecasts later tomorrow. And I'm just kind of taking a quick look here. I think this is probably the outflow, the old cold fronts through Nebraska here, up into southwest Minnesota. And then the dry line, that's receded almost all the way back to Beekman, Colby, Sheridan, kind of in that area right there. And if we want to do the moisture axis, I'll do that real quick. Let me check the analysis method just to make sure we don't waste too much time. Nearest neighbor, perfect. Okay. Let me plot the mixing ratio. And we can see that pretty well. There's the moisture axis right in that area here. So wherever that MCS is, wherever it's intersecting this moisture axis, that's going to be the most conducive to strong thunderstorms. So as it moves into the Minneapolis-St. Paul area a little bit later, maybe a little bit of potential there for strong storms. So it's a combination of this and your storm relative inflow. Those are two things you want to be looking at. Okay, this hour infrared looking like this. You can see the storms there in the northern plains. Few cells all the way back to Nebraska, and then what looks like either some debris or higher cells across central Kansas all the way down to the Paducah-Guthrie area of Texas. Can't tell much about moisture though, just looking at infrared. There's the water vapor imagery. This gives us the mid and upper level moisture, not the low level moisture, so don't get confused about that. Looks like a little bit of the deeper upper level moisture has returned to the eastern Gulf. I remember we had that vortex that kind of swept eastward into Florida and out into the Atlantic. That kind of messed things up, but it looks like the air mass has recovered in this area. And then we go out to the west and we can see the subtropical jet. You can see the very striated look to the moisture field right through that area there. This is what Minnesota looked like earlier in the day before the convection really got going. So this is all the tropical air flowing north through Iowa and Omaha. It's got kind of a hazy look there. I guess maybe that's cirrus through that area. But you can use these charts here early in the morning to find the boundaries. Not very apparent at this hour, but looks like maybe something like this. And then there's a southern boundary right here around Fargo all the way down to central South Dakota, and I think this is actually where a lot of the storms got going earlier today. And then a quick look at thickness and isobars. Well, we've definitely got the Gulf open. You can see a couple of pressure lines through the Texas area. So we're bringing the low-level moisture up to the north. And we see a little bit of thickness packing in this area right here. That's indicating that we've got maybe a bit of a stationary front through this area. We've certainly seen something move through the Four Corners area a couple days ago, and it looks like the wave has actually moved northeast, and we find it now up in the North Dakota area. And then the warm front, that's pretty much supported by the map about where we saw on the surface chart, so that looks consistent there. Then we pick up this trough here in the Delaware area into New Jersey. So I think that's probably the tail end of that other front, just off the Long Island coast right through that area. And let's see, I think that's going to bring us to the skew-ts, and we'll take a quick look at the Aberdeen skew-t, since they definitely got some severe weather there. This was Aberdeen at 0Z. I think it might be more helpful to look at Aberdeen earlier this morning. So I'm going to set these variables back a little bit to the 13th at 12Z. Okay, so we're looking at the Aberdeen skew-t this morning. Definitely got some steep lapse rates from 850 all the way up to 500. So that's good for severe weather. We've got some very strong winds aloft. Got good mid-level winds also. And we see a little bit of north wind going on near the surface. So I think we've had some sort of front in the area. We may be a little bit too far north to sample the moisture, so maybe we need to go a little bit further south. That's definitely good for the upper level conditions, but let's check out Omaha here. That can be a little bit more representative of the low level moisture. And I see maybe 12, 13 grams per kilogram, a few thousand feet deep right there, and look at that capping, very well capped. If we lift that with maybe a high temperature of 90, that's going to be our lifted parcel there. Definitely some good cape, but a lot of inhibition. Yeah, that's very, very significant inhibition. But we know the moisture quantities. We can see that right down here at the bottom. 14 grams per kilogram. So if you go up to Aberdeen and kind of like factor that in, 14 grams per kilogram, throw in some heating up to 85. Looks like the capping is not so strong, right? So that's kind of how you go about playing with these skew-ts. You take ingredients in one area, you advect them to another area, you look for dynamic changes. You can definitely go to the models to see the trends on those, and you see if you have initiation. And I'll bring up one more chart here. Let me go to, geez, we got nothing between Omaha and Aberdeen. That's bad. Why can't we get a sounding at Sioux Falls? I guess I'll bring up North Platte here. North Platte's showing that 14 grams per kilogram there, so a lot of consistency there in the low moisture. And there's the capping, also a factor there. Warm things up to about 90 degrees. Capping still holding pretty tight, very high cape, but that convective inhibition, keeping things shut down in that area. And I think they did get storms later on during the evening, so probably there were a little bit of dynamic changes during the afternoon, maybe a little bit of shortwave energy. And that's the reason I look at these charts here. Did we have any upper level lift? Definitely looks like it. Let me run this back to yesterday or this morning's data. So if you're forecasting for South Dakota and Nebraska, you're looking at this area, you're seeing not very much in the way of dynamics there. And then as the day goes on, yeah, definitely some short waves heading for that area. There's one here, another one there. There's 18Z. Yeah, that's going to change things. And destroyer capping, 21Z. Working very heavily on the air mass in the central South Dakota area up to North Dakota. And one very important factor here is how far equatorward that dynamic lift is. And you can see, looks like the southern edge of that is right there. So anywhere in east of this line, not getting much change in the mid and upper levels. So you would not look for any weakening of the cap in the Omaha area, Sioux Falls, and so on. But definitely weakening as you go west. And then by 0Z, yep, quite a bit of energy working there northwest of Omaha and west of Sioux Falls. And probably a little bit of convective feedback going on right here. That's going to mess with the models a little bit. Okay, probably about time to head into the forecast, and let me just connect with everybody in chat here. Got Justin. He says this time slot really works for him. Hope your family enjoyed the night out. I appreciate it. Mike Guestwick says, anyone home? Yeah, we were a couple minutes late there. Burl H says, good evening. Death Valley. Fun with Tech says that Death Valley will hit 122 on Saturday. Glad I will not be there. Me too. Mike Guestwick says, hello, fellow weather geeks. Alexi is here. Ron Chalfant, nice in Southern California today, getting hot the rest of the week. Tom J is here. Ronald Martinez. Dwayne Ward, late night here on the East Coast. Past Tom J's bedtime. Some people getting a little bit of lagging there in their stream. I'll let you know what's going on. I did make one change to the stream. Let me show you this right here. And I've been doing this for about 2 nights now under advanced settings. There's this option down here called stream optimization. I've got it now set to optimize for interaction, low latency. I previously had it set to this other one, less viewer buffering. And I don't really know too much what the difference is, but I did notice when it was on this other one, if you joined the stream like maybe 10 minutes in, it would start you from the very beginning. So the chat and the content would not be synchronized. And I thought maybe that would cause some problems for people, so I set it to this other one. So if you're noticing any big problems from that, let me know. And if necessary, we can change that back there. Sessions becoming information dense. Yeah, I tried to give that a hack tonight, but I was not able to get my stuff together in time, so I'm probably going to have to do a little bit more of that tomorrow. I don't have my notes all put together here. I had to rush to put the stream together. Megan John says, storms rolling through Minnesota right now, watching the gust front out ahead. 82 degrees where Mike Estwick is. Let me get some of that radar data going there. 82 in Denver there. Justin getting quite a bit of lag. Hiker, Arizona, 114 degrees expected Monday and Tuesday. Wow. Robert Terrell has been pitching about 107. Incredibly warm and humid there near Minneapolis from Megan John. Victor Cabot checking in here. Tom J going to Phoenix on Father's Day. Only 115 forecast. And just scrolling through the chat here real quick. Megan John looking at velocity readings on the storms there coming into, I think, Minnesota. Alexi says there's audio skipping a little bit and some buffering. Justin says those YouTube settings probably explain it. With my internet speed, it may be best to give the buffer leeway so quality can degrade rather than it drop out when your upload speed dips. And Victor says he's getting clipping as I pause or end statements. Well, there's two ways around that. I can either switch that back where it was last time. And I'm talking about that setting here, optimized for less viewer buffering. I don't know if that will absolutely get rid of it. The other is I can change the bit rate on my end and bring the bit rate down. That might help a little bit also. So I'll go ahead and finish up here. We're looking at the storms coming into Minneapolis right there. They are definitely outflow dominant. There's the outflow boundary. And we're seeing that outflow boundary about 11 miles ahead of the storms there, so that's a good indication that they are really pushing out a cold pool, and that's not conducive to severe weather. Now, the strong storm relative inflow can keep them going for quite a while, but it's going to be very hard to get a supercell pulling together in this kind of pattern. Can't see it on spectrum width too well, maybe a little bit through this area right here. Storm relative velocity, though, that often shows it very well. There it is right there, that outflow boundary. So reds flow away from the radar, flowing this way, and then green, component of motion towards the radar. And some of the strongest inbounds that I'm seeing out here along Route 212 around Glencoe. VIL is something that I sometimes use. This is a integration of all the reflectivities in a column from the ground all the way up to the stratosphere, and this can give me a quick look at where the storms are most severe. And I actually find that the better VIL products are on radar scope, and I'll show that to you maybe sometime in the next couple of days. Radar scope has a very high resolution VIL product, and I like using that, especially when I'm very far from the radar. That can help me identify the more isolated storms. In this case, the storms are getting kind of close to Minneapolis there, and I can see that these are the cells I would want to focus on when I'm kind of jumping on shift. And also this other one here, north of, looks like Milwaukee. So yeah, we can see that very strong storm right there. Maybe the outflow boundary maybe pulled a little into that cell there, and then the other strong VILs That was in this area right here. Okay, so that was the storms right just directly east of Minneapolis, about 40 or 50 miles or so. Anyway, doesn't look too bad. Looks like some very beneficial rains coming in and a very prolific trailing stratiform region coming in. Maybe we can see that on the cross section. Well, very hard to see. There's the convective elements right there out ahead of the line. And then way over here, that's the trailing stratiform area. And it's been my experience that this is a good area for cloud-to-ground lightning. If you can get any view above the scud clouds, you can get some very great lightning shots in this area back in here. So that's a look at what this trailing stratiform area looks like. Higher reflectivity is up to about 20,000 or so. And what you would see here is just kind of a giant anvil covering this area. And usually where I have the highest reflectivities, there seems to be a tendency for very strong positive strikes in that area, like in here and back in here. And that has something to do a little bit with the jet coming in the lower levels and the storms themselves feeding ice crystals back westward, and the charge separation between those particles. And let's see here. Let me go back to the chat and see what's going on. Radar scope is the bomb. Yeah, we've shown radar scope a couple times on the webcast. I've got a program here for viewing stuff off my tablet. We'll have to do that. Jumping flash, not experiencing any lag, so the lag could be local for some of our viewers. Pickle 3, pretty good too. Megan John, northwest of the cities. Alexa uses radar scope more than Pickle 3. Justin's asking, how's the stream for others? Good question. And good morning from Baltimore. Okay, so let's move on and look at the forecast here. Let me kill the lights. It's getting really warm in here. I was going to run the webcam earlier, but I can't get that running just yet. Okay, we're going to look at the NAM3. Okay, so overnight, here's that MCS moving eastward through Minnesota and Iowa. This is going to be about midnight. Looks like that starts dissipating out by the Quad Cities, around La Crosse, and western Wisconsin. And then this tail end here, outflow boundaries out in this area. So we're going to be watching this area from Des Moines to Omaha during the morning hours. That could be an area for regeneration. So midday looks like one little area developing in far northeastern Minnesota or Missouri. And yeah, there's our redevelopment right there. Kansas City out to Whiteman Air Force Base, Columbia. Looks like we've got a couple strong cells moving southeastward through Minnesota and around Veneta and Miami, Oklahoma. And those will sweep into the northern Oklahoma, or the northern Arkansas mountains, into the Muskogee, Tulsa area overnight. And the million-dollar question is, will this keep going south? I've seen a few times where the models have decayed this during the morning hours, but the storm actually continues progressing southward into Texas and Louisiana. So if that happens, we're talking about Thursday morning for that. So we'll keep an eye on that. So anyway, basically looking at the MCS tonight over the northern Midwest, shifting tomorrow into Missouri and eastern Kansas, and then possibly down into the Red River Valley, Arkansas, Texas, Louisiana for Thursday. And I guess we'll wrap this up with the GFS. Okay, looking at things synoptically. Big Bear Clinic low there over in North Dakota. That's the main Bear Clinic low, and there's the cold front. And there's the warm front, MCS out ahead of that. And what we're going to see over the next 24 hours, Bear Clinic low becomes occluded, moves up into Manitoba and Saskatchewan, and then the new Bear Clinic area focusing there on Minnesota. So by the time we do the webcast tomorrow night, looks like maybe a cold front from Minneapolis down to Omaha, down to Dodge City, and then the warm front all the way over to Sault Ste. Marie and over to London, Ontario. And then the occlusion all the way northward to Winnipeg, and maybe some cold core showers up in that area. But anywhere down this cold front, also remember we have some boundaries, mesoscale boundaries being indicated there by the NAM3. Those will be a good area for development. Those could push southward and towards the feed of low-level moisture coming up from the south. And then for Thursday, let's see, what do we have here? Looks like maybe a little bit of a Bear Clinic area there around Michigan, upstate New York right there, and maybe some sort of tail end system in Oklahoma. I think this may be the scraps of that old outflow boundary that is pushed south into Arkansas. And remember, these global models do not have good skill with the mesoscale details, so we're just kind of taking a guess what's happening here on Thursday. I think there may be some potential there for afternoon thunderstorms in this area, the Red River. We'll see how that pans out. Then moving ahead to later on Friday, Great Plains low gets going, and we start tapping the Gulf once again. Pretty quiet according to the GFS. Looks like we've got the warm front moving back northward. So maybe something like that there for the polar front. And yeah, look at that. Some storms blowing up overnight along that front right here. You notice that's pretty close to where I drew that front earlier. Maybe a bit of a dry line intersection through that area here. And we've got the moisture flowing up northward from the Gulf, and that storm complex looks like it is diving south straight for that moisture. Okay, then for Saturday, new frontal system diving south, and there's the setup. Chance of the storms anywhere from Minneapolis down to Des Moines and into Kansas. Then for Sunday, cold front sweeps southeastward. Looks like it makes it all the way down into Texas. And then for Monday, tail end of the front moving down into Texas, so we will have a boundary in our area driven by this high pressure region. Gulf is not open, but we've got a lot of residual moisture in this area. And then let's see here for Tuesday the 20th, start to develop some return flow. Warm front moving up through the Midwest, so thunderstorms for that area. And then we pretty much get to the end of the run there. The run is not finished, but frontal boundaries look to be something like that. Looks like a pretty good polar front coming together in northern Nevada and California there. So maybe spring is not going to quite be over yet. Let me just take a quick look at the upper level patterns here. This is going to be tomorrow night. Looks like the flow kind of weak over the Missouri area, so not a whole lot of help for whatever gets going in that region. But for Thursday, also pretty weak. Subtropical jet affecting Texas, so any storms that do make it south, they'll be augmented by that stronger flow aloft. Polar front jet well to the north, and that'll stay to the north over the weekend. We see almost 100 knots through that area right there. And then towards the end of the week next week, still up in the northern plains there. So I guess most of the big storm action will be up in that region, but any boundaries that move to the south, those will definitely have the potential there to produce some rain and that kind of thing. Okay. Dwayne Ward says GR kicks butt, uses both radar scope and Pickle 3. Always cool to see storms retrograde. Greg Schultz says late night, getting ready for severe weather in Wisconsin tomorrow. Tornado yesterday, not far from there. And Dwayne Ward, haven't had a good setup in a while there in the mid-Atlantic area. Okay, I think that's about all for me since it's almost midnight here. Hopefully we'll see y'all tomorrow. Thanks for joining, and have a good evening, y'all.